So analysis of frames and machines. Let me put a few words there. So these are structures, I would say, which one of the members is a multi-force, I'll call it this way, multi-force member. Right. Well, if you want to add an explanation there, you should know what multi-force member is. A member which is, I don't know what it is, so which is acted on by 3 or more forces. If there are 2 forces, it's just going to be a truss. Now, what's the difference? Frames, let's put it this way, frames, when we talk about frames, let's say typically stationary and designed to support loads. Now, simple examples, I have a couple of pictures I pretty much took from different textbooks. Let me see if I can find them. Just have them here. So what we are talking about when we talk about frames. It's a crane or 2 cranes. You can think about these as frames. Now, what are they frames? We said we can be a simplified version of them could be a truss. But in this case, we have these members that if you pay attention to those, right? Typically, if it was just this one and a load there and a support here, it could be just a truss. But now we have this extra member there. Right? So this member right now is a 3-force member. Right? We have a support here, at least 3-force member. We have a support here. Right? Let's just look at it as some support. You have this force applied to it, right? The green line, which is coming from the hydraulic piston and cylinder to just lift it up and down. And we have this load hanging. Now, you might ask me, this could be also a machine because it's kind of transmitting the force. You're correct. If it's just standing still, you can look at it as a frame. If it's actually moving, you can look at it as a machine. So as I said, it's not really that easy to distinguish between in so many cases. And we don't even care that much about the exact difference. Another example, a very simple study light, right? Some light you use on your desk or somewhere. Typically, it could just be a truss structure, but now we have extra members there, right? If this is just a member, we have extra components that apply the force. So if this is the member, you have another component there, you have some component here. Right? So this one member, shown by blue, is a multi-force member, right? Forces are applied to it, not just at the end, they're applied to it in different places. Think about machines. Now, machines, again, pretty much similar story. The only difference is that they have moving parts. And we can add to this and are designed to transmit, or I would say probably carry the effect of force is very wordy though, but the effect of the forces. Examples. Let me see what I got there. A very good example would be just something like this. Tools. You see actually them very frequently. They go into the category of machines. Right? There's something that they have moving parts, and they're designed to transmit the effect of force. When you apply pressure or force on this side, it's transmitting the force you apply with your hand to the object you're trying to hold. What else? Let me see if I have more stuff. Look at this one. Yeah, it's a bulldozer or any kind of machine that you use. A lot of construction machines that, well, as we call it, a machine, is also machines. Some dimensions there, you can just ignore that. But they have moving parts, and there are members that are multi-force. Even more advanced, you can think about robotic hand. Right? It's some robotic hand that well, maybe later on you take robotics, and you'll be more familiar with this topic and how things work. But that's also a machine. It has multi-force members, and typically it's used to transmit the effect of force. But if you see something and you cannot distinguish or you cannot classify that whether it's a machine or it's a frame, you don't need to worry about it that much, because the way we analyze these two structures are pretty much the same. All right, so this is just I would say a review, because when I started talking about analysis of structures, we talked about frames and machines. Now, how do we analyze frames and machines? Right? I can give you a general procedure. Right? The way we do it, we isolate each part, and we pretty much represent all the forces and I would say couples that act on each part. Keep in mind, now we have a machine that can handle bending. Right? Before, when we were talking about truss structures, we said the only type of loading on a truss member could be compression. The truss member could be under tension or compression, meaning that because we had two force members, those two forces should have been aligned. Remember, back then we were talking about two force members. Those two forces, the lines of action for those two forces should be aligned. That's the only way that a two force member or a part or a rigid body is in equilibrium. If they are not aligned, they're going to create a couple, and the object starts rotating. Now, when it comes to frames and machines, you have multi-force members, and you're going to, as a result, you're going to see couples and moments on your members. So as opposed to before, that, or different from what we had before when we had a member, now you can have a member that there's a force somewhere in the middle. Right? And so this force can actually create a couple or moment about any other point, except the point it's passing through, on this member when you look at this rigid body diagram. And since now we are talking about frames and machines, and obviously you can apply force on any part, we have to deal with couples and couples too. As I said, forces can create moments. As a result, they could be also couples. Right? Moment of a couple, some moment or couple applied somewhere on this member, because it can handle a couple. The members in a truss could not do that. They could only handle axial forces. So that's a distinct difference. So things get, as a result, things get a little more complicated, right? You have parts that they can have force applied to them in any direction, and you're going to have couples added to the whole scenario you're looking at. So how do we analyze these? Right? We saw to analyze trusses, we said method of joint, method of sections. Now, when it comes to frames and machines, we have to go back to what we learned, the fundamentals. Right? We have to look at each part what we learned about how analyze rigid bodies, single rigid bodies. Now we're going to dismantle a frame or a machine we're looking at. We look at each part or isolate each part, draw the free body diagram for each part, right, in this machine, right, and put all the forces and couples they're acting on this member. If you have a two force member, great. We just put two forces that are collinear, right, acting in their wherever they're applied. If we don't, if they have more forces, if you have more forces on a member, we just draw the free body diagram, including all the forces and moments. And one thing you have to pay attention when we dismantle members or parts of a frame or a machine, and then you also have to take into account the internal forces. Right? As the first example I looked at when we started talking about analysis of structures, that when we dismantle one part, you have to pay attention to the internal forces, the interaction between that part and the part that it used to be attached to. Right? There are some interactions, and those internal forces should be taken into account. Let me write the general procedure, then we look at examples and things probably make a little more sense. So let me put it under procedure. So be more procedure to analyze machines and frames. I don't know why I'm writing machines and frames. All right, there you go. So step one, just isolate all, or I would say isolate each part and show all the forces, all the internal and external forces, all the internal and external forces and or couples you can say that act on the part. Step two, right, keep in mind, or I would say for all the two force members, so checklist, I have two equal but opposite. We talked about two force members, right, when we're talking about rigid bodies. Now we're just going to go back to the fundamentals again, because each part is going to be a rigid body, so we have to treat it that way. But opposite, let me use the word collinear here. Collinear, meaning that the lines of actions for these two forces should be aligned. Collinear forces acting at their point of application. Third thing I wanted to you can just write that. What did I do there? I wrote, okay, use the equation of equilibrium to find the unknowns, or to analyze the structure, or to find whatever you're looking for. And so this is very general procedure that you have to follow to analyze. Right? So this is a little different from trusses. Right? Here there is no method of section, method of joint. Go back to dismantle them, draw the free body diagram for each part, and pretty much write the equation of equilibrium.